NASA wanted to show the remote manipulator system could handle the 2.5-ton payload.
And TJ, we just turned on the mass spec to warm it up. I assume that you wanted us to do that. Okay, TJ, we're with you, and John performed a beautiful release.
The orbiter's ability to station keep with SPAs was also demonstrated. At this point, they are 1,000 feet apart. Here, SPAs and Challenger are 200 feet apart. Thrusters on board the orbiter were fired to record the effect on SPAs. SPAs is rebirthed for return to Earth.
I've been told that some crews in the past have announced that we deliver. Well, from Flight 7, we pick up and deliver. We certainly hope so.
The remark by Shuttle Flight 7's commander meant not only had the SPAs operation been successful, but that the crew also deployed 2 communication satellites. A Canadian satellite to be used for one of the world's first direct-to-home pay TV services, and an Indonesian satellite. It would increase high-speed data transmission and telecommunications service to that country's remote island locations.
Roger, the weather at KSC is getting worse instead of getting better, so it looks like we're a no-go for KSC.
Shuttle Flight 7 was to be the first landing of an orbiter at Kennedy Space Center, Florida. But bad weather conditions did not allow it. Challenger would touch down instead at Edwards Air Force Base, California, the alternate landing site.
Roger.
During the period of communications blackout, usually lasting about 15 minutes, temperatures on the vehicle's surface reached their peak. The temperature of the red-hot glow seen through Challenger's front windows was about 2,400 degrees Fahrenheit. One astronaut described the view as like being inside a furnace.
Processing Wilson to transmit. Real good, Chris.
Been running about 5 to 7 minutes around trim on the right.
Roger, see that.
I'll say once more, we're waiting on the California.
Roger that. Challenger Houston, rolling off the hat. Your energy looks good. Surface wind 180 at 10.
Challenger is well done.
Roger, we see that. Congratulations. Green left landing.
Roger that.
Approximately 2 months after TDRS was first launched from Shuttle's cargo bay on Flight 6, the final firing needed to place the satellite in its correct orbit was executed.
Copy. Go ahead for the burn.
Personnel began immediately to check out communication systems on board and initiate a series of important ground tests with the satellite essential to its operation on upcoming shuttle flights.
Processing TDRS.
First use of TDRS with Shuttle was on Mission 8.
Challenger Houston with you on TDRS.
Houston, Challenger, loud and clear. Have you raised CDR?
Roger, loud and clear also.
Challenger, this is Houston with you through Hawaii for 7
Also
minutes.
conducted on Shuttle Flight 8 was checkout of the remote manipulator system and payload flight test article.
You're loud and clear too, Dale, and looks like you're right on schedule.
The 8,500-pound structure was the heaviest object lifted by the arm to date, more than double the weight of any previous payload. Data gathered during the checkout was used to plan the Solar Max repair mission. On that flight, a 20,000-pound payload would be deployed, and an orbiting satellite would be retrieved.
0008.
We're ready to deploy. That's good news.
Flight 8 marked the 6th successful launch of a satellite by Shuttle. It was an Indian communications satellite which would bring telecommunications, television, and badly needed weather information to remote areas of that country. Because Challenger was launched at night on Shuttle Flight 8, parts of the southern hemisphere never seen or photographed from space were visible during daylight hours. The first night landing for the Space Shuttle program occurred on Mission 8 with safe touchdown of Challenger at Edwards Air Force Base, California. After making its first voyage into space on Shuttle Flight 4, the Continuous Flow Electrophoresis System, CEPHIS, flew again on Shuttle Flights 6, 7, and 8. The device is a prototype of a production unit to purify material for the treatment of disease. It was built by McDonnell Douglas Corporation and flown on Shuttle as part of a joint agreement between NASA, McDonnell Douglas Corporation, and Ortho Pharmaceuticals Corporation, a subsidiary of Johnson & Johnson.
Challenger, Houston.
Combined results from Flights 6 and 7 demonstrated that CEPHIS could separate over 700 times more material, and in purities 4 times higher than could be achieved in Earth's gravity. Shuttle Flight 8 was the first use of CEPHIS to separate living cells. Some of the samples were separated to continue research at Pennsylvania State University and Johnson Space Center, Texas. The McDonnell Douglas samples were used to further diabetes research at Washington University Medical School, Missouri. Other scientific activity conducted on Shuttle Flights 5 through 8 also focused, as the CEPHIS had, on research and materials processing, greatly enhanced when performed in the weightlessness of space. The monodisperse latex reactor flown on Shuttle Flights 3 and 4 flew again on missions 6 and 7 in a continuing attempt to improve the production of polystyrene latex microspheres for cancer research and treatment and glaucoma research. 5 student experiments flew on the 4 shuttle flights as part of an annual science competition co-sponsored by NASA and the National Science Teachers Association. Studies ranged from fluid convection to sponge and crystal growth to biofeedback. A total of 23 getaway special canisters were flown on Shuttle Flights 5, 6, 7, and 8. Some contained stamped envelopes from the U.S. Post Office commemorating spaceflight. Others grew snow, exposed seeds to zero gravity, and studied the effects of weightlessness on a colony of ants. NASA's Getaway Special program is a unique opportunity to fly small, self-contained payloads on board Shuttle on a space-available basis at a very low cost. Perhaps the studies with the most human interest were those done on space adaptation syndrome, also known as space motion sickness, a malady which affects approximately half of all astronauts. The most extensive studies of SAS were done on Flight 8, focusing primarily on the neurological system. Oral sensitivity was tested, eye movements, and repeated physical motion. Measurements were taken of limb volume and external tissue pressure. If any of these tests looked torturous, it's no wonder the crew dubbed the doctor's mid-deck working area a chamber of horrors, and mockingly gave him a taste of his own medicine. Astronaut crews got along exceedingly well with each other on missions 5, 6, 7, and 8. Yet they were the largest, most diverse crews in the history of spaceflight. Flight 5 carried the first 4-person crew. Flight 6, calling themselves the Over-the-Hill Gang, tallied up all their years of experience to get this grand total. Flight 7 carried the first 5-person crew, including the first American woman to fly in space, Sally Ride. Flight 8 included the first black American to fly in space, Guion Bluford. And the oldest person to fly in space today, Dr. William Thornton. With ejection seats gone from the flight deck, and water storage tanks and instrumentation gone from the mid-deck, there was much more room to accommodate the larger crews. There was also opportunity for privacy, exercise, and as usual on any important trip, plenty of food. The success of Flights 5, 6, 7, and 8 represented many accomplishments for the Space Shuttle program. More importantly, the missions proved the operational capability of the space transportation system, that useful work can be done in space for the benefit of people on Earth. But the program has really just begun. Third orbiter in the shuttle fleet, Discovery, will be launched in 1984. The fourth orbiter, Atlantis, will be ready for use in 1985. New astronauts are being recruited. 73 shuttle flights are scheduled through 1988. The outlook for the future of America's space shuttle program is excellent, and there appears to be no end in sight.